In a previous video, we talked about how to solve linear systems using the linear combination method. In this video, we will show another example of that requires an additional step. Remember in the previous video, what we did was we added together both of the equations, term by term, in order to eliminate one of the variables. If we take a look at this system, if we try to add together each of these equations term by term, will any of the variables be eliminated? We'd add an x with an x, which would give us 2x, the x would still be there, and we would add 2y plus 7y, which would give us 9y. We would still have the y's. So simply adding these two equations right now isn't going to do us any good. So now we're going to have to introduce a new step into this process. We're going to have to adjust one of these equations so that one of the terms does have the opposite of the other, so that when we add them together, that variable will go away. In this system of equations, it's relatively easy to see how to get one term in one equation to be the opposite of the corresponding term. Look carefully at the x's. All that we would have to do is make one of the x's be the opposite of the other. If we were able to do that, then we would have an opposite x and a regular just x, which when we add together would go to 0. We can do anything that we want to both expressions in an equation as long as we do the same thing to both expressions. So let's take this first equation. What could we do to the first equation in order to make this be an opposite of x, a negative x? We could multiply both sides by -1. So let's go ahead and do that. We can multiply both sides of an equation by the same thing without changing the value. Well, if we want to multiply the left-hand side of this equation, since there are terms, we need to get it in parentheses. And we can multiply it by -1. And we can also multiply the right-hand expression by -1. And now, we will rewrite both of these equations right on top of each other to the right-hand side here. So we're going to need to distribute this -1 into both terms. So this is going to give us, in our new equations, -1 times x is the opposite of x, plus -1 times 2y is -2y. So we've taken care of the left-hand expression. Now we have to multiply the right-hand expression by -1 as well. So this is going to be 5 times -1, which is -5. In this case, I don't have to do anything with this second equation. I can leave that just as it is, so it's going to come straight across x plus 7y equals 10. Notice that all I've done here is multiplied that very first equation by -1. That's all that I've done, which is a legal mathematical move. If you multiply both expressions by the same thing in an equation, you haven't changed the meaning of the equation. Now look what we've done. We've made it so that these x terms are opposites. So now we can employ the strategy that we used in the last video of adding these two equations together. From here, the strategy is the exact same as the strategy that you've already seen in the previous video. This is the only extra step. We have to make sure that we can get one of the terms to be able to cancel. X plus -x is 0. -2y plus 7y is 5y. And -5 plus 10 is 5. And now we have eliminated the x variable, so the only variable left in this new equation is y, which we can easily solve for. The only step here is to multiply both expressions by the reciprocal of the coefficient. This will leave me with y equals 1. Remember, whenever you're solving a system of equations, you're not finished once you've found the first variable. You have to find both variables. So the only variable I know is y. I now have to use one of my original equations to solve for x. I'm going to use the first equation, which was x plus 2y equals 5. And I'm going to substitute in the value that I found for y equals 1. And I'm going to rewrite this equation, x plus 2 times y, where y equals 1, equals 5. simplify the left-hand expression. X plus 2 times 1 is 2 equals 5. And now we're going to get rid of all terms without my variable in it by adding the opposite. And this will give me x equals 3. So I've now found my ordered pair. I found the x value and the y value, so I can put them together into my solution, which will be the ordered pair x equals 3. So it'll be the ordered pair 3, 1. Now when you're solving systems like this, sometimes, like in the first video, or the last video that we did, you will be able to simply add the two equations together. You have no prior work. In this problem that we solved in this video, we had to manipulate one of the equations in order to make the variables opposites. By the way, you could have manipulated the second equation instead. You could have multiplied this by -1 instead. You would have still got the same solution. If you'd like to give it a try, that would be a good challenge for you. In a future video, we will explore systems of equations where both of the equations need to be manipulated in order to find solutions.